From the first principle, we have to find the derivative of y equals x to the power of 3. Now we have y equals x raised to the power of 3. So here, don't forget, as the value of x changes, the value of y too will change. So here we introduce y plus change in y equals x plus change in x, everything to the power of 3. Now, what next? The next thing is we are going to subtract y from both sides. Subtract y from both sides so that we'll be left with change in y here. Everything equals x plus change in x raised to the power of 3 minus y. So before we proceed, let us try to substitute the value of y here so that we have change in y equals x plus change in x raised to the power of 3 minus what is our y? Our y is actually x to the power of 3. Now we want to solve x plus change in x raised to the power of 3. Let's quickly use our Pascal triangle from the binomial theorem. Remember that we are having x plus y raised to the power of 2. The coefficient will look like this: 1, 2, 1. So when you have x plus y to the power of 3, always remember that you will start with 1 and you will also end with 1. Then the next thing is these two together, you add 1 plus 2, we have 3. 2 plus 1, we also have 3. To make it simpler, you're going to have xy, 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 xy. Now, as the value of x is decreasing, the value of y is increasing. The power that we're dealing with here now is 3. So we have for x 3, 2, 1, 0. For y 0, 1, 2, and then 3. Now y to the power of 0 is 1. 1 times 1x cubed will still give us x cubed. Now y to the power of 1 will give us y. So this is a x to the power of 1 will give us x. Okay. X raised to the power of 0 is 1. 1 times 1 is 1, which you can clean. Then we now join them with plus. So what we're saying is if you're having x plus y, this will raise to the power of 3. This is going to be our answer. Now let us bring this to compare. X plus change in x to the power of 3. So x remains x, y is now changing x. So whenever we have x, we have x to the power of 3 plus 3, x is still x squared, while our y is change in x. Then plus 3x, our y is changing x, so change in x squared. Then plus y raised to the power of 3 is actually change in x raised to the power of 3. So which means if we simplify x, if we expand x plus change in x cubed, this is going to be our final answer. Now let us come back to this very place that we were before, that is change in y equals, we have just solved this. What did we get? X cubed plus 3x squared change in x plus 3x change in x squared plus change in x to the power of 3. Then don't forget we have minus x cubed. Minus x cubed. So x cubed minus x cubed, we cancel x cubed as we are having change in y equals 3x squared change in x plus 3x into bracket change in x squared plus change in x to the power of 3. There's change in x here, there's change in x here, there's change in x here, so let's factorize. Change in y equals change in x into bracket. So when change in x goes here, you are having 3x squared plus, when change in x goes in change in x squared, you'll be having 3x change in x, then plus, when change in x goes in change in x cubed, you have change in x squared. Now the next thing we are going to do is we multiply through by 1 over change in x, or divide through by change in x. x. So let's divide through by change in x. So change in y over change in x equals change in x into bracket 3x squared plus 3x change in x plus change in x squared. So everything over change in x. So this change in x will cancel this change in x. Now we have change in y over change in x equals 3x squared plus 3x change in x plus change in x squared. Now, the limit of change in x approaches 0, change in y over change in x equals, so what I see here is anywhere we have change in x here, we put 0. So it will give us 3x squared plus 3x times 0 plus 0 raised to the power of 2. The limit of change in x approaches 0, change in y over change in x. Everything here is the same thing as dy dx equals 3x squared. This is because 0 times 3x will give us 0, 0 squared is 0. So our dy dx equals 3x squared. So this is a solution to the derivative of y equals x to the power of 3 from the first principle. In the next class, we'll check the other way around of solving our derivative without stressing ourselves by going through the first principle. So see you in the next video.